Okay, we are live and broadcasting. Okay, we'll get it going. So I'm just opening up that. Okay. When you're ready, I'm ready personally.
I'm ready.
Get comfortable and pull up the right things. All right, so we're doing lesson 4, correct?
Yes, sir. So, is everyone's in there then?
Yes.
So, question 3. I'll go ahead and read it. Human blood can be classified into one of our basic types, O, A, B, and AB, in the population of the United States, with each of these blood types is summarized in the following table. The blood types and proportions given in the table above define a probability distribution. I would say true. Would you guys agree?
Yes, because all the numbers must add up to 1.
Yep.
Okay, perfect. What is the probability that a randomly selected person in the U.S. has an O blood type? Answer that, sorry. I didn't mean to read that.
So let's see. It's 9/20ths, or 9 out of 20.
I think it has to be in a decimal form.
I'm pretty sure in the preparation assignment, it asked, let's see. Maybe I'll find it. I'm fairly certain that it stated that probabilities are given in fraction form. But let me go back.
It wants us to give it in a decimal form.
Oh, does it say that specifically? Oh, yeah,
Again?
round 2 decimal, that would be specific.
Is it 0.45? Yes, 920 is equals 0.45.
That's what I was going to guess as well.
And I was
Anyone
going
else?
to put down 45.00%, which may or may not be right.
I think that we put it in the 0.45 because it always rounds to 1, right? I mean, always we're adding up to 1, so it should be 4.45.
Right, which is equivalent to 45%. So I'm just looking at the lesson here to see what it would.
Well, and the homework, it wanted us to put it in decimal and not in percentage form.
Yeah, okay. Yep, looks like decimal it is.
So that makes the next one be that they will not have typo.
Hey, can you guys hear me again?
Yeah, we can hear you now.
Oh, great. Awesome. I had to open it up in a different window or something, but my camera still doesn't work. Sorry about that.
Yeah.
Hey, that
You're very in and out.
twice. Oh, we'll not have it. So it would be everything combined, or it'd be 0.55, right? On question 5?
Yeah,
Yeah, that's what I was going to put down.
I got 0.55.
Perfect.
Yep.
That's perfect. Who wants to read the next one?
I will if you can hear me.
We can hear you.
Yeah, go ahead.
Caroline Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. So if the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round to 3 decimal places.
Let's see, it's 1 out of 7 total, right? Yep, 7 bowls.
Yes.
So that's 0.143.
Yep, that's what I got.
Yes.
And so there's little evidence. Would you guys agree that that the dogs can detect bladder cancer?
Are we doing number 7 now?
Yeah.
So in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? Statement A, this provides strong evidence that dogs can detect bladder cancer. Or B, there is little evidence that dogs can detect bladder cancer.
What's your guys'
322 divided by 54. I use A.
Yep, I would agree with that.
So
statistically, isn't that pretty low?
It's near, or it's just over double of what would naturally occur randomly. But my thing is, chances are it's still a skill that's being learned by the dog. I mean, it's in trials, so they haven't perfected it entirely, and the dog hasn't perfected it, but he can tell. Some definitely. Others are a little harder to
So they're
detect.
saying 50% of the time?
It's 40.7% of the time.
22. Sorry, yeah, you're right. That's so 40% of the time they're getting it right.
Yeah.
So to me, that I would feel like, I don't know. Maybe maybe I don't understand that. Is there any? Can you explain that reasoning again one more time? Sorry, I just want to make sure I understand it.
Okay. So, let's do a kind of an analogy. So playing basketball, you get a professional, you know it's possible to score, right?
Mhm.
You get a kid, they might shoot 100 times and not make any. And it's the level of training there. So given random chance here, we would expect about 14%. But based on the level of training, the dog's not perfect at it, but it's still about 2.5 times higher than random chance. And so it's strong evidence that the dog can detect bladder cancer, and it just needs more practice. Does that make sense?
Yeah. Is there anything in the class that makes you feel that way? Or like, in my mind, I'm just like, well, if someone told me that there's a 40% chance that this dog can do it, I would say, well, anything under 50 is not probable.
I would say just based on the chances of 1 out of 7 and being 2.5 times above that is pretty above the average chance or your random chance of getting that.
Okay.
That's my argument. Will, what do you think?
I read something in the homework where it talks about the likeliness of what's his name, Christopher Columbus drawing it out, and then it's like it talks about like a strong likeliness or a weak or not likely probability distributions. I don't know where I read that. I'm trying to find it again so that I can just reread it because it's better on here than it is in my own words.
So,
But I
well,
would
what are
definitely
you?
say it's a strong.
You would say strong.
Yeah, I would say strong.
I think that was in the homework as like in the rating assignment. It's talking about if Christopher Columbus and the rest of his crew draw one being what is most likely is 2% of the time they draw the being with the cross.
Yeah.
It's under 2.1, under less than 4.
Okay. I'm just gonna study that on my own later, but I'm gonna go with the group because you guys all agree.
Okay.
M&Ms are fees. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. A bag of plain M&Ms. What is the probability of drawing a red-colored candy? 0.13.
Yep.
Yes.
Yes.
Agreed.
Green. And then we need to figure it out for green.
Yeah. That's what I got as well.
Yes. Where is it? Point. It'd be just reverse. The reverse of the last answer.
The next one.
Or I guess. Yeah. 0.84. It's almost the same question as question 5.
Sorry, Will, were you trying to say something?
Yeah, it's almost the same question as question 5, where you just flip it around. Did you hear me?
Yes, that's exactly right.
What rule would that be? 2?
Yeah, rule 2.
I can't
The
remember.
sum of all numbers, or of all probabilities, is equal to 1.
Yeah.
Well, actually, it's rule 3 because it's the complement rule. The probability that it's not occurring is 1 minus the probability.
Okay. I'll read the next one. Can you hear me?
Yeah.
The ACT score of students admitted to a medium-sized public university in the western United States were taken from capex.com. The following summary statistics were calculated. The mean, standard deviation, variance, minimum, Q1 median, Q3 maximum, interquartile range. Half of the observations are less than or equal to what number?
I got 24.
Yep,
Yeah.
24.
Yes.
The median.
It's funny because I have gotten mean and median confused my whole life. But mean is average. Average is mean.
I completely
Well,
agree
they're
with you.
both averages, but mean is the mean one because you have to do the calculations.
Yeah, and then median is the
Oh,
middle
that's-
number, right?
Yeah,
Okay.
they're both
And then
averages.
the next one. Yeah. So the next one's just quadrant 3, so it's 27, right?
Yes.
Yeah.
And then the one that's not one of the rules.
The third.
Yep. If the probability is high, then the probability is positive. That one. If the probability is.
Yeah.
Technically, I
See.
think the nope, never mind. Yeah, no.
What?
Question or answer number 2 is also incorrect because it's a number equal to or greater than 1 and less than or greater than or equal to 0 and less than or equal to 1. Not between 0 and 1.
Wait.
But that's an aside.
No, it's
It's
between
just
0.
poorly written.
Oh,
Wait. So we're putting.
Because they need to be fixed.
The third one is the correct answer, but the second one isn't worded correctly.
Okay. Did you guys all are we submitting it now?
yeah, I submitted it already. Got 100%.
Hooray.
Yay.
Hey, it's the first time I've
I'm
gone
glad you
100%.
did it. Well, I'm glad to hear that you got 100. So, were there any other questions about this lesson before we do the next one?
Nope.
I'm gonna try and explain the 0.143 to you again. Am I coming in clear?
Sort of groggy, but we can still try it.
So like with all those examples they gave of like winning the lottery, your odds of winning the lottery are not strong, right? But those are like 0.000000 something, you know? But like the chance of a dog being able to smell bladder cancer was like 14, like 1 in 7. So that's pretty good. That's pretty strong. I don't know. Yep, maybe you can find a video about it or something, but
Yeah, no, I think I. Are you guys ready for me to set up the new one?
Yes. Do it to log off and dial back in. How that's going to work?
So I just have to invite you guys to another call. So if you just end this one.